Hello friends, welcome to this 11th video in set theory which will deal about Warshall's algorithm. So what is going to be the prime purpose of Warshall's algorithm is to find the transitive closure of any given relationship. In the last video we saw about what is meant by closure. Closure of a relation is nothing but if you have a base relation and we need any additional input or like topping on top of the closure on a desired type of relation, like we need a reflexivity to be added to the existing relation or symmetricity to be added to the existing relation and so on. So we add up the requirement and then form a new relation, and this new relation which takes in for the old one and the requirement is called by the name called as closure. So when we want to compute the transitive closure of any relationship, then Warshall's algorithm is going to be the best suited one because it is easy in nature. So we will have the 3 steps of Warshall's algorithm to be gone through. Let the initial marking of the iteration W0 be equal to the matrix of the relation. So from your relation, draw the matrix of the relation, mark it to W0. So in first step what we do is, we transfer all the ones in the old step to the new step. So from the old, all the ones are transferred to the new iteration. Next what we do is, we go on to pick all the ones in the columns. Notice the first one which we pick up for is going to be columns. This is your PIs. And then what do we pick up? Wherever we have the entry to be equal to 1. We pick up the positions where my entry is 1 in my column. Next I move on to the rows, and then for these rows again I pick up wherever the entry is going to be equal to 1. So in this new position of Pi, Qj, in the new iteration I am going to input extra ones in the positions Pi and Qj's. So I am going to repeat this iteration again and again. So how many times will the algorithm run for? So if my cardinality of A, cardinality meaning the number of elements of A is going to be equal to n, then my iteration will run for Wn. So if your A consists of 3 elements, so your cardinality of A will be equal to 3. So your iteration will be running for W1, W2 and W3. So for 3 runs the iteration will run for. And what you obtain at the final stage, that matrix has to be further converted into a relation type to get the transitive closure of any given relation. So we will quickly land up into the problem and see how things work over here. Problem number 1, let A be the set 1, 2, 3, 4 and R be the relation 1, 2, 2, 3, 3, 4 and 2, 1. Using Warshall's algorithm, we will have to find the transitive closure of R. So what is going to be the initial step? Initial step is going to be fixing your matrix of relation by the basic iteration W0. So what do we do over here is find the matrix of relation. Quickly recollect how to write the matrix of relation 1, 2, 3, 4. So it is a 4 cross 4 matrix 1, 2, 3, 4 and again I have a 1, 2, 3, 4. So how is this matrix will? Wherever we have the relation, the matrix takes the entry value as 1. And if there is no relation, then the matrix value is going to be 0. So 1, 2, 1, 2, 1, 2 will take the entry as 1. Next 2, 3, 2, 3 will take the entry as 1. Next 3, 4, 3, 4 will take the entry as 1. Next 2, 1, 2, 1 will take the entry as 1. So from the given relation, I have formed the matrix of relation MR, and apart from the positions where there are going to be 1, the remaining positions are marked as 0, which means there is no relation in these positions. You will have to keep one basic thing in your mind. We are doing an algorithm with this going on with your iteration. So each and every iteration will generate a new matrix of relation, that is it will generate new ones. That's what transitive closure requires, because already there is a relation from A to B, there is a relation from B to C. What we need to generate is going to be something like a relation from A to C. So it is generation of relation. So whenever you generate new relation, what happens? You will be generating new ones. So my prime target is to generate new ones out of the given existing quantity or the existing matrix. So for this, I have 4 elements in my matrix, set A. So the cardinality is 4, so we will be computing W1, W2, W3 and W4. The final W4 which we get will be called as the matrix of the transitive closure, and from here I can write the relation of transitive closure, which is denoted by R infinity. We will be following a tabular format for this. So whenever you take it in your examination, make sure you keep it in lengthwise and do, so that it will be comfortable for you. You need not have to turn your pages. You can refer each and every stage in a single click and then you can complete it. And one more important point you will have to keep in mind is, every time you take an input, the input has to be the final answer generated from the last stage. Don't go back to your older versions. You take the current matrix for your next computation, because every iteration will generate an output. This output is given as an input to the next iteration. Okay, so next again this input will generate an output. This is given as an input to the next iteration. So every time you take the matrix, you will have to look into the current output and not the older ones. So if you keep this little hint in mind, then you will not go wrong. And the second thing is that you will have to first collect the columns and then you will have to collect the rows. So we will begin with the first iteration. This is going to be my initial iteration W0, and now I go with my first iteration number 1. I need the position of ones in my column 1 and in my row 1. So first what do I do is I mark my column 1. Which is your column? Column is something that is going to be vertical. So you can make column is something, it is vertical. And what is going to be row? Row is something that is going to be horizontal. So first mark your column. Which is your column? This is my column. So I marked my column. Where is the position of 1 in this column? I have 1 in position number 2. So what do I do? My columns 1 is present in position number 2. Okay, now I move on to make the position of 1 in the row, in the first row. So what do I do again? I mark my first row. Okay, this is my first row. Where do I find a 1 over here? I find a 1 over here. This is my position number 2. So my 1 is present in position number 2. Okay, first go for the column. Check where is 1 present. Mark those position. Next, go for row. Check where 1 is present. Mark those position. Okay. Now the new ones will be placed in your position Pi, Qj. This is my Pi, Qj. So it will be placed in the position 2, 2. So how to get the first matrix W1? So for my W1, what I need to do first is, so go back, check. Transfer all the ones from your Wk in your Wk minus 1. From your Wk minus 1, transfer all the ones. So for my 1, what was my prior stage? W0. So what will I transfer? I will transfer all the ones. In the remaining positions, I will just make them as blank. Don't make it as 0, just keep them blank. Okay, so I am having this ones. That is my step 1, transfer. I have marked the position. Now I am going to put 1 in the new positions. So what is going to be the new position? 2, 2. So this is 1, 2, 3, 4. 1, 2, 3, 4. What is the position 2, 2? 2, 2. This position which is blank, this will now get a new entry called as 1. So my first iteration is over. I have filled the old ones and now I have filled the new ones, and whatever is left out as blank over there, mark it as zeros. So I have marked the remaining positions as zeros. So this completes with my iteration number 1. I hope the steps is clear. Next I move on to iteration number 2. So for my iteration number 2, which matrix I will have to refer? I will have to refer to the matrix of iteration number 1. Keep it in mind. Don't go back to your older one. So what we have now as an input is my new matrix W1. So which is going to be my column I will have to refer to? It is going to be k equal to 2. So go for second. So this is going to be my second column. So where do I find ones in my second column? 1, 2, 3, 4. This is 1, 2, 3, 4. So tell me where is the position? It is present in 1, it is present in 2. So in 1 and 2 I find ones. Okay, in a similar way mark your second row. So this is my second row. Now tell me where is the position of ones. 1 is present in 1 and 1 is present in 2, 1 is present in 3. So I go mark it as 1, 2, 3. In position 1, 2, 3 I find my ones. So where will be the new positions now? The new position will be combination of pi comma qj. So it will be 1 comma 1, 1 comma 2 and 1 comma 3. Similarly, it will be 2 comma 1, 2 comma 2 and 2 comma 3. So now my next target is the new matrix W2. How to get the W2? First, I need to transfer all the ones from my older matrix to my new matrix. Where is the position of 1? Okay, so now I transfer all the ones from my old matrix. Next, I'll have to fill this with the new ones. So where are the new ones present? New one is present in 1, 1, 1, 1, get a new 1. 1, 2 already has a 1. 1, 3 gets a new 1. Okay, 2, 1 already has a 1. 2, 2 already has a 1. 2, 3 already has a 1. Okay, so I am done with the new ones. I have generated new number of elements and that completes iteration number 2. When iteration number 2 is over, fill the remaining positions with zeros. So my iteration number 2 is over. Now this will become an input to my third iteration. So what will happen in my third iteration? Okay, I am going to refer to W2 now. Now I go to look to column number K. What is column K? Column 3. What is my column 3? This is my column 3. So mark your column 3. So where is your ones present over here? 1, 2, 3, 4. 1, 2, 3, 4. Where is 1 present? In 1, 1 present in 2. So I have 1 to be present in 1 and 2 in my column 3. Next, go for your row 3. Where is my row 3? This is my row 3. So where is your 1 present in your row 3? Here, I have a 1 present in my row 3 in position number 4. So where will be my new pi comma qj generated? It will be in 1 comma 4 and it will be in 2 comma 4. So these are the new position for my ones. So how will I get my current matrix W3? First I will have to transfer all the old ones. So transfer the old ones 1, 1, 1, dash, 1, 1, 1, dash, dash and 1 and dash everywhere. So this is 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now where is the new position for my 1? It is the position 1 comma 4. 1, 4. So this place gets a new 1. Where is the second one to be present? 2 comma 4. 2, 4. So this position gets a new 1. So now I am done with the new entries. So all the leftover entries have to be marked as zeros. So we are done with the third stage. You will have to keep in mind how many stages the algorithm will run for. The algorithm will run for cardinality of A. And what is the cardinality of A? 4. So I need one more iteration to be completed because only in W3 I need to move to W4. Okay, so we will move on with the fourth iteration. For the fourth iteration, this will become my input now. Okay, so now keeping this as an input, I will move on to fourth iteration. In column 4, I will have to take. So mark your column 4. This is my column number 4. So where you are present your 1, 2, 3, 4. 1, 2, 3, 4. Where you have ones present in your column 4? Position 1, position 2, position 3. 1, 2, 3 has 1s in your column number 4. Now go for your row number 4. Which is my row number 4? This is my row number 4. And when I see the row number 4, do you have any 1s present over here? No, I don't have any 1s present over here. That is, I don't find any 1s or notice any 1s. In which case, I cannot make any new 1s or generate new 1s. So there will be no new generation. If there is going to be no new generation, then the current matrix for your W4 will be remaining to be the same as your W3. And hence, what will be the final? 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 0, 0. So this is my final matrix that represents the transitive closure. But I want the relation of transitive closure. So this will be a part where normally we miss it in a hurry in exam. So what is going to be the relation of transitive closure? You denote it by R infinity. Now from this matrix, rewrite your relation. How to rewrite the relation? It was just the reverse process of your construction of MR. So what you do, 1, 1 position, you have 1. So what enters over there in the relation? 1, 1. Wherever you have entry 1, mark an entry in the relation. So 1, 2 is here, 1, 3 is here, 1, 4 is here. Next I have 2, 1, 2, 2, 2, 3, 2, 4, and last I have a 1 over here in the position 3, 4. Okay. So these are the entries for my transitive closure. So this completes the full problem on Warshall's algorithm. We'll quickly do one more problem so that we get accustomed to the methods. So this completes the final stage. There is no entry, and so this is the final matrix out of which you will write the relation. Okay. Problem number 2, you have directly been given the matrix 1 0 0 1 0 1 0 1 0 0 0 1 1 0 0 0 1. Okay. So 4 cross 4, cardinality is 4, so I need 4 steps to be computed. So step number 1, let me go. This is going to be marked as my initial stage W0. So I need column 1. I'll go and mark. This is my column 1. Where do I find my 1? This is my position of 1. The position of 1 is going to be 1. Okay. And next I go for my row 1. So where is going to be my 1s present? This is 1, 2, 3, 4, 1, 2, 3, 4. The 1 is present in position number 1 and 1 is present in position number 4. So where will be the new 1, 1 and 1, 4. So I will have my W1 generated. The first thing is I need to transfer all the old ones. So this will be my old ones which have been now transferred to, and now I insert my new ones in the position 1, 1. 1, 1 already has a 1 here, and 1, 4 also already has a 1. So I don't have new ones to be generated. So the process is now filling the remaining places with your zeros. So I am done with my first iteration. So this first iteration's W1 will be given as an input to my second iteration. Okay. In my second iteration, what I'll have to do, I will look for my column number 2, which is my column number 2. This is my column number 2. And where is the position of 1? Position of 1 is going to be in second position. Next, I move on to row number 2. Where is my 1 present in my rows? So it is present in position 2 and 4. 2 and 4. So it is 2, 2 and 2, 4, the new position for my ones. So my W2, what I need to do first, copy paste all the old ones. Okay, so old ones are being copy pasted for, and now the matrix is ready. Now insert the new ones. Where is the new ones inserted? In the position 2, 2. 2, 2 already has a 1, and 2, 4 also already has a 1. So there are going to be no more new insertions. So I complete the process by filling the remaining places with zeros. So I am done with my W2. This becomes an entry for my W3. In the next stage, this becomes your new matrix. Okay, so this, using this, we move on to step 3. In step 3, you look into your column number 3 and go for your ones. Do you find any ones? No, I don't find any ones over here. So will there be any change? And then you go for your row 3 where you are having 1 over here in the position number 4. Okay, so since there are no entries here, there will be no change. So your W3 will be the same as your W2, no change. So 1 0 0 1 0 1 0 1 0 0 0 1 and 0 0 0 1 will be my W3. I need 4 iterations totally, so this W3 is given as an input for my last iteration, which is W4. So in my W4, the 4th iteration, which column I'll have to refer now? Refer to the 4th column. Okay, so where are the ones present over here? I have ones everywhere over here. 1 2 3 4. And now go for your row 4. Where do you find 1? 1 is in the last position, so position number 4. So the new ones are generated for 1 4 2 4 3 4 and 4 4. So these are the new position. So I want a W4. So what will I do? I copy paste all the old ones from your W3. So this is what we have from the old pasting. So this is going to take the new entries in the position 1 comma 4. 1 comma 4 already as a 1. 2 comma 4, this also already as a 1. 3 comma 4 also as a 1. 4 comma 4 also as a 1. So there are going to be no more new entries. So we can complete the task with filling up of zeros. So I have now ended up with W4. That is going to be my last stage. So I have my W4 to be generated. So W4 is going to be generated, and hence what can be the final matrix of transitive relation R infinity? My R infinity will be, you have your W4. This is going to be your W4. So collect all the ones and write what is the relation. So what is the first element? 1 comma 1, 1 comma 4, 2 comma 2, 2 comma 4, 3 comma 4 and 4 comma 4. So these are the pairs where I find ones, and hence they form the transitive closure of your given relation. I hope you understood the concept of Warshall's algorithm, primarily aimed to compute the transitive closure of any given relationship. Run the iteration for n cardinality of the number of elements or present over there in the sets, and you will have to make sure that every time you take the new entry of your matrix and not the older ones, so that the new ones, you mark the corresponding iterations row and column, and then pick your new PIQJ and then mark the new entries. I hope you understood the Warshall's method. Happy learning. Keep learning.